Embedded World. It is day 2. We're very excited to be here. Day 1 was really exciting. And we're here at the booth of NXP. We're going to talk about a really exciting announcement. So at Embedded World, we made few announcements, but this live stream is to you for a very exciting one. Maybe you have already heard about it. We announced it on Monday. It's about us expanding our MCX portfolio with our freshly newly released MCX-W. So what I can tell you is that we're adding wireless to our MCX portfolio, but more importantly, I'm here joined with 2 NXP experts that are going to give you a little bit more exclusive details about this announcement, and hopefully are going to answer all of your questions that you have. So I'm joined here with Sujata Naiding. Thank you for joining me here.
Hi, Monica. So good to be here.
And Charlie Ice.
Hi, Monica.
Hi. And I'm going to ask them a few questions. And afterwards, if I didn't answer all of them, you can still put them in the chat box below, and we're going to be sure to address them. So Sujata, to you, what exactly are we announcing at Embedded World for wireless at Embedded World, and what are you most excited about?
Well, first of all, you kind of touched on it already, so I'm really excited to expand the momentum we have with our MCX portfolio and bringing wireless connectivity to that portfolio with the MCX-W series. So the MCX-W series with rich connectivity is built on the same architecture as the MCX portfolio and also supported with the same unified developer experience. Now, what's unique with the MCX-W is that we're bringing the wireless connectivity aspect into these devices, and we're announcing the first 2 families in the MCX-W series. That is the MCX-W71 and the MCX-W72 families. These are pin-compatible, scalable, and secure wireless MCUs that support Bluetooth Low Energy, Zigbee, Thread, and Matter, to support the range of applications that we're seeing in industrial and smart home markets.
Speaking about smart home, I know that Matter has been a big topic here at the show and as well in general. What can the MCX-W bring to Matter developers? Can you tell us more about that?
Sure. So Matter is a new standard for interoperability targeted for the smart home that is developed and deployed by the Connectivity Standards Alliance. So it's an industry standard to drive interoperability, and what that does for consumers is it brings flexibility and choice and just this peace of mind that the devices they bring into their host will work together seamlessly and securely. Now, what we are doing for product manufacturers of these smart home devices is bringing the MCX-W series to enable them to create designs with a platform approach. With the MCX-W71 and W72 being pin-compatible families, they support a range of applications and device types that Matter supports today and will continue to add in the future. We provide flexibility in the memory size between these pin-compatible families, and we also support standalone or hosted architectures so that we can support the wide range from simple sensors or battery-powered applications like door locks to more complex applications like thermostats and hubs and gateways. So with the pin compatibility and scalability and unified developer experience, we're providing developers of smart home devices, especially for Matter, a complete tool set to build what they need.
Okay. Maybe another thing that the Matter developers may be concerned about is that it's a rather new standard, and they may be concerned about any future versions of the standard. So does the MCX-W provide any future proofing for developers?
Yes, so one of the key capabilities and differentiation with our MCX-W71 and W72 families is that we have architected it to have a radio subsystem. So there is a dedicated radio subsystem that has its own core and memory to support it. And what this brings to your question about changing and adapting to new versions of the standard is that we can make these updates through providing firmware images that can be deployed to even devices that are in the field instead of having a fixed function radio implementation. And another key advantage that this radio subsystem brings is that we're able to offload the main application core by putting the wireless connectivity, low-level drivers or full stacks, depending on whether it's the MCX W71 or W72, and that enables a more robust experience, more robust wireless operation.
Okay, it seems like our Matter developers are safe, but are they secure? I know that security is also a big topic for our developers, so can you tell me something about the MCXW?
Yes, so you're absolutely right. Security is a key care about for all product developers of IoT devices, as there are growing threats of cybersecurity attacks and also awareness from consumers and users about these types of attacks. So Matter has taken this into consideration as a key design tenet of Matter and implemented security in how Matter devices form a network. When a Matter device is added to a network, it has to prove that it is who it says it is, so it proves its identity, and it has to prove that it has certified itself with CSA and that it's an officially Matter certified device. And the way that Matter does this is that every device must be injected with the device attestation certificate that proves its identity and authenticity. With the MCXW series, we have an embedded EdgeLock Secure Enclave core profile. So this is taking our security IP and embedding it directly into the wireless MCU to support crypto acceleration, secure key and certificate storage, secure debug, and secure boot, as well as we support this with our EdgeLock to Go service. So the EdgeLock to Go service is what helps product developers inject these device attestation certificates in their devices. We are authorized by CSA. We're the only silicon provider that can provide this capability for all of our customers or other product developers in the industry. And we are able to generate and then deploy those device attestation certificates through the cloud directly to our customers' manufacturing sites. So with the MCXW series, we're equipping product developers for Matter applications with all of the tools they need to develop, design, and deploy secure Matter devices.
That sounds really great. It seems like our developers are really safe and secure. Thank you so much, Sujata, for your insights.
Thank you.
Charlie, hi.
Hi, Monica.
So a question to you, what other technologies actually beyond Matter can the MCXW bring?
Well, with MCXW, we are excited to announce the first wireless MCU to support Bluetooth channel sounding. And Bluetooth channel sounding is a new technology from the Bluetooth SIG that is allowing two Bluetooth devices to securely and accurately measure their distance. So we're now able to securely and accurately measure the distance between two Bluetooth devices much, much better than we were in the past.
Well, the first MCU to support channel sounding, that sounds really exciting. Can you tell me how does this fit with the UWB, with ultra wideband?
That's a great question because both technologies are used for ranging and used for what we call locationing, where we look at how far apart two different things are using wireless technology. And really the two actually fit hand in hand because ultra wideband is great for really, really fine, precise ranging, close-in ranging, whereas channel sounding is good for secure and accurate longer distance ranging, or ranging where you don't need as much precise accuracy as you might need with the ultra wideband. And so if you combine the two together, you get a complete locationing technology solution.
Can you give me an example?
Yes, of course. A door lock is a really good example of that. So in a door lock, you might have the user with the smartphone in their pocket, and they would walk up to the door. Bluetooth would be used to establish a secure connection, and then Bluetooth channel sounding would be used to do the ranging kind of far away from the door as the user walks up. And once they get real close to their door, then ultra wideband would turn on, do that close-in, last mile, precise ranging, and then the door would know exactly when to unlock the lock because the ultra wideband is so precise. But channel sounding would be used to that longer distance, kind of coarser, close-in ranging. Again, with that improved accuracy and improved security, that we get from Bluetooth channel sounding.
Wow, seems like channel sounding sounds very interesting. So I guess my last question will be, or like for the developers, what they are maybe interested about is will be leveraging the Freedom development boards, and will be how can our developers get started today?
Well, we are absolutely going to be leveraging the MCU Espresso developer experience with MCXW. MCXW is an MCX, so with all of our other MCX series, we are also being part of the MCU developer experience, which includes Freedom development boards. So we'll have MCXW Freedom boards. We'll also give developers their choice of whatever IDE they want to use, including VS Code. We'll also have the application code hub support for lots of code snippets available very easily directly from nxp.com. And then finally, we'll have our connectivity stacks available both with MCU Espresso SDK and through the GitHub from NXP. So same developer experience that we've seen with all the other MCX series that has been well received by developers.
Great, that sounds really exciting. And we came live on day one, and I promised our audience that maybe we're also going to show them a practical sneak peek. So coincidentally, we're sitting in front of a demo.
Right there.
Right there. Do you want to show me and the audience like how this actually works?
Sounds very exciting. Let's do it. So this is our channel sounding demo, and it has two different pieces. This is an example of a thermostat enabled with channel sounding. Here you can see the MCXW channel sounding board. And then this is a display driven by an NXP RT crossover MCU. And then the second board here is another MCXW channel sounding board. And this board represents a user's smartphone that would be channel sounding enabled. And so the user would have their smartphone in their pocket with channel sounding. And as they walk in, then the AC would know how far away they are. And so it would turn off if you're far away. And then as the user walks into the conference room, it would measure the distance to their phone, detect how close the phone is, and then automatically turn on the air conditioner. So this is a great example of how M6W combined with channel sounding is really enabling new innovative IoT technologies, and as well as driving more energy efficiency in things like smart buildings.
Well, thank you so much, Charlie, for showing our audience this live, and thank you, Sujata, as well, for all your insights. I hope we have managed to answer all your questions, but in case we haven't, please put them in the comments below, and we're gonna make sure we address them. Thank you, everybody, and I hope you're as well excited about this announcement.